In this video, we're going to talk a little bit more about how you can create vectors to hold the results of your for loop calculations. So just as a refresher, what we did with the birthday problem was something similar to the following. So we started out by creating an empty vector. Let's call that x. I created an empty vector here by using the C function, which C stands for combine or concatenate. And it's usually meant to glue together the elements that are passed in to form a vector that is given on the left-hand side. Because I'm passing in no arguments into C, what it's actually doing is just creating a very empty vector. So you can see that when I run this first line, it tells me that x exists in my environment, except it is null or empty. So next what I do is I go about writing a for loop, and I'm going to iterate this, let's say from 1 through 1000, just for fun. Maybe we want to calculate the reciprocal of I. And as you know, if I just write my for loop like this, the results of my calculation don't get stored anywhere, which means I can't actually look at the results of this calculation after the fact. So in order for me to store this somewhere, I want to specifically store it into x. What I'm going to do is use this C function again, because again it acts like glue to put together the elements you put in into a vector. So what I did with the birthday problem is to simply put in the existing value of x as the first argument and the new calculated value as the second argument. So let's see, I'm going to run this whole thing and then we can look at the results. So head of x will give me the first 6 elements here of my vector, and you can definitely check that these are indeed reciprocals of the integers 1 through 6. You can also look at the tail of x to check that these are the last 6 values in x, and they sort of make sense because the last number here is exactly 1 over 1000. So it turns out that this particular way of storing results in a vector is not at all efficient. The reason why it's not efficient is that at every step here, what it's doing is creating another copy of the existing vector x, appending this newest value to it, and then saving that over the original variable x. So a better way of doing this is not to set an empty vector, but rather to predefine how long this vector is going to be. And in my case, I know this very well. I know that I'm going to store 1,000 different reciprocals, so my vector should have length 1000. So in this line of code, what I've done is made use of this rep function, which rep stands for replicate, and basically what that does is it takes the first argument that you pass it, and it repeats that however many times is as indicated by the second argument. NA, by the way, means not available. It is a reserved value in R that stands for something that is currently missing. So here I am still creating another vector that really doesn't contain any useful information. So I just ran that line of code. And as you can see, now Y just contains 1,000 placeholders for potential values to be filled in later on. They're currently all NA. So now we're going to try to fill this up inside of our for loop. So my for loop, for the most part, will look identical as before. I'm going to do my 1 over I calculation. But instead of taking that 1 over I and gluing it to an existing vector, what I can do is use the square bracket notation to index the ith element of y and store my computation into that particular space. Okay, so as you can see, I will start out being 1. So the first thing that I do when I enter this for loop is to say, let's modify that first entry in y and make that 1 over 1. And then when I gets updated to 2, then I'm then accessing the second element of y and updating that to 1 over 2 and so on. So I'll go ahead and run these lines all over again. And you can see that indeed y and x are at least agreeing in the first 6 and the last 6 elements. And if you trust me, they're all going to be the same. I claim that option 2 is more efficient than option 1, and you can sort of see why, because instead of trying to make many copies, you've basically allotted how much space you're going to use, and you're slotting in the latest value into the correct slot at each time. But just to really demonstrate that this is indeed efficient, let's crank up the number of calculations that we want to do. So instead of doing 1,000, let's go all the way up to 100,000. So I have to make that change in 3 places here. So that becomes 100,000, that becomes 100,000. And I'm going to then just run the second option and show you how quickly that completes. That took no time at all. So we can go and click on head and tail, and you can see that these are exactly what you would expect. So let's now try to do the same thing using option 1. So at this point, you can see where my cursor normally would be for me to type in the next line of code. You would expect a sort of greater than sign here, which would be R's way of telling me that it's ready for new commands. Right now, I'm not seeing that greater than sign because R is still computing through this for loop. You can also see that there is this stop sign up here, which will be activated when you can have the option of stopping a particular calculation. Well, now I guess it's actually done, but you could see how much longer it took to run this set of lines of code compared to the option 2 more efficient method.